Hello everyone. Welcome you all to the Tech Gig webinar. Thank you for joining the session today. The topic of today's talk is Demystifying Security Data Science Part 2. It will be an 1-hour session with around 40-45 minutes for the presentation and the remaining time for the Q&A. So if you have any questions, kindly send them to us using the question tab on the GoToWebinar control panel. I am Vedant, the moderator of this session, and it gives me great pleasure to introduce you all to a guest speaker, Dr. Satnam Singh, PhD Chief Data Scientist, Evalkio Technologies. Dr. Satnam Singh is leading security data science development at Evalkio Technologies. He has more than a decade of work experience in successful building data products from concept to production in multiple domains. In 2015, he was named as one of the top 10 data scientists in India by Analytics India magazine. So without any further delay, let me introduce you all to a guest speaker. Over to you, Dr. Satnam.
Thank you, Vedant. So welcome everybody to 2018 and also to the Tech Gig webinar. So it's my pleasure to meet you guys again for the part 2. Last year when we met, I know roughly been 2 months now, when we had the part 1. During the part 1, I discussed about security data sources and InfoSec use cases, and I primarily focused on the anomaly detection part of it, where we saw a few demos on using anomaly detection and specifically about InfoSec use cases. So today what we'll do is we will change the topic. We will discuss more about supervised machine learning use cases, and also we will see the real demos as well. And I will also talk about a few tools and tactics that are used by the attacker. So let's get started. Well, attackers are using the tools which are also used by the admins. So that's what makes it very difficult to detect them. They use ipconfig, task list, who am I. These are the simple commands which are everyday users, and also the admins also need to use them. Now, if attacker is using them, it's very hard to differentiate who's an attacker and who's a normal user, right? The same things for the reconnaissance commands as well, like netview, netuser. These are the commands which are used by the attacker as well. And attackers are using some of the tools which are used for the pen testing as well, like Metasploit, Mimicache, and Nmap. Now, the same tools are used by attacker as well. Now, this is what adds to the complexity. The tools and the commands which are used by the admin and the normal users are also used by the attacker. Now, the question really comes that what are they after? I mean, if they are within the enterprise network, they are primarily after the customer data. They want to steal the customer data and basically for the money. They want to sell it on the dark web and make money out of it. And some of the attacks are more like nationwide attacks. In that case, they would be more focused on specific documents as well for a specific enterprise or a specific government agencies. So the motivation could be different from depending on what type of attackers they are and which category they belong to, in a sense. Are they novice, advanced? Are they nationwide attackers? And also they, if they are more after the money, in that case, they would also like to use ransomwares, which was prominent in 2017. We heard about the WannaCry. Not only heard, I mean, we had the incidents of WannaCry, lots of them in India as well. So what are their techniques and tactics? It primarily starts with phishing. they would do a social engineering and craft emails which will be pointed for a specific set of individuals to prompt them to click on it. And once it is clicked, then the payload will get downloaded on their desktop or on their laptop, and the user won't know it. And after that, the malware uh, or the payload communicates with the command and control, and then it propagates into the enterprise, and also it escalates to a higher level privilege access so that they can uh, move towards where they need to go. So if you look at from the attacker perspective, the very first thing they would like to know is where they are in the network, right? And so in a sense, like if they have compromised some host, they would like to see in which part of enterprise they are. Now they would like to see, okay, they have to go to some of the higher uh, admin host, or like admin who has a web access, so web server access, so that they can take over the website. Now, it's depending on the attacker motivation, right? Or they would like to go to the database admin so that they can take over the database access. So that's how their tactics and techniques involve. They have an objective in mind, and in order to reach that objective, they have to also do a lateral movement within the enterprise so that they can move. While they are doing all these lateral movements and also the reconnaissance and as well as the exfiltration of that data, they obviously leave some traces, right? They obviously leave some signals. And the blue team can use those signals to detect them. Now, what I will discuss that as a blue team or as a defense team, how can we leverage the data to detect the presence of an attacker and of their tactics and of their activities as well. So let's look at some of the data sources and as well as the use cases. So these data sources, I will describe more into the different buckets, like the net from the network point of view, from the endpoint point of view, and also from the user authentication point of view. But before that, we also need to talk about that as a blue team, where we are. Like, what is the evolution trajectory we have seen over the past few decades? So if you look at the trajectory of the blue team or the security data science as such, it started with a rule-based system for intrusion detection system and intrusion prevention system for network, and then also for the host as well. And then still it is being used very heavily. Like tools like Snort is a very good ideas, uh, and there are other IDS and IPS tools which are also commercial offering as well. Those are offered by Cisco and multiple other companies. So the goal of the IDS and IPS was more like at the perimeter, look at a specific signature in the packet or in the packet metadata as well, and then block that packet. So that worked for a while, but then attackers found the ways that, okay, these are the ways, these are the data types which, as a blue team, looking at it. See, for an example, the IDS is looking at in the HTTP traffic, so they started getting into the HTTPS traffic, so that is encrypted traffic, so you can't, the IDS and IPS can't look at the payload anymore. So they started evading these defense systems. Then came the data mining based anomaly detection, which started looking at more at the net flow and also more at the higher level attributes of, let's say, user behavior analytics, where we as a community we started leveraging the big data in terms of all the Hadoop and the Spark ecosystem to make a profile of each host and each machine, each user as well, and each entity in the network, and then compare it with the baseline. And if there is any deviation from the baseline, then trigger an alarm. So that also was predominant till the 2015 or so, and it is still used very heavily. Another thing we have to keep in mind that all these security systems are used in a layers. There is no such thing that if you use only one system, then it is going to secure. It is always the security is sort of like a problem, like an onion problem. So there are multiple layers at which we have to secure ourselves, our network. Uh, and with that spirit, let me get into the the various layers and the various logs which we collect at different layer. See, so first layer is a network log. So if you look at this particular picture, it shows that there there are modems and routers and firewall, and the hosts are connected. It's sort of a star topology, which is 95% of the enterprises have a star topologies. Now this shows for a one VLAN or subnet, it could be hundreds of them in an enterprise. Now using IDS, IPS, we collect lots of data, and that data could be in the form of firewall logs or net flow or DNS traffic or HTTP traffic and so on. Now, in my part one webinar, I discussed more of anomaly detection use cases. Here, I'm going to talk about more supervised machine learning use cases where we could leverage the label as well. So in some cases, we could actually label him, like see, for example, application attack detection, like OWASP top 10 attacks. Those could be labeled, and we could label them with the signatures and with the packets and with those features. Now that data we can train a machine learning classifier, and when we deploy it, then it's gonna predict whether this particular type of attack is going on or not. The same thing is for the network intrusion as well, network intrusion detection as well. So one thing to keep in mind is the net flow and the network logs as such, all the logs which I've listed here, that is a very high volume of data, and it could easily run into a few terabytes per day, depending on the organization size. So the next set of logs and the layer, which is the endpoint itself, right? Depending on the organization size, you may have thousands of employees or hundreds or few tens, depending on the organization size, and the log size would vary accordingly. So at the endpoint, if we start monitoring each file system, application, and process and the OS log, then it easily runs into the terabyte as well. So this kind of data can be leveraged to figure out if there is a malware which is running, or if there is an anomalous process running over there, or anomalous application running over there. So in the supervised setting, what we could do is we could train the classifier beforehand for the known cases, and then the classifier can predict if there is any malicious process or malicious application running on that endpoint. the same thing can be leveraged for the spyware and a ransomware detection as well. User authentication logs are another set of logs which captures a very meaningful and informative knowledge about the user activities. And this is a very useful log for user behavior analytics. We could detect suspicious sign-on activities, brute force attacks, and also detect the infected or compromised hosts. Privileged user logs, Active Directory logs, and the Windows event logs are also, I'm sort of like clubbing into this particular category, but they all add a very valuable information, sort of like different cameras to look at the attacker's activities within uh, the enterprise. Now, each of these is a very detailed topic, and I can't get into for each log. But what I would do is later on, I will show you a few demos which are leveraging some of these data sources. So let's talk about a little more generic pipeline. So generic pipeline is we get the logs like this, and this is just one example of it. We typically need to have some kind of a log processing done, which is done in some kind of a SIM, which is called Security Information and Event Management System. And there are some open source and there are some commercial products as well for SIM. This one shows a picture from a Splunk, and there is a free version of Splunk can be also leveraged. Elasticsearch and Logstash Kibana is another option as well for log processing. We can take the logs and we need to convert into some more of a structured form where we can give it to the algorithms. So in this particular case, we have leveraged Splunk and converted into key value, and those key value pairs are being indexed and also converted into a structured form in Splunk. Now, as you can see here, now it became more of a columnar table where the columns are the various attributes and the features. This one shows the SSH activity in the enterprise, and it shows the source, destination, the IP addresses, and the particular source type as well. And it shows that what is the event type also. Now, in a traditional security operations center, security analysts would be looking at these and they would be primarily investigating based on their heuristics and their hypothesis. Now we have to leverage the machine learning and data science. So over there, we have been talking about the two key buckets. One is anomaly detection. In the case of anomaly detection, we create a baseline and then we say that, okay, what are the things which are away from the baseline? Those are the anomalous, and let's look at those anomalies. So in this case, it shows that there are anomalous services which should be investigated by the analyst. Or we can take the data which is available along with this label. So in this case, we had the data for a script, which is PowerShell script or any other kind of a script, but we have the label whether this is a malicious or a benign, and then we can train a classifier and we can say that, okay, yes, for any unknown script, how likely it is this one is a benign or malicious. So let's talk about a little more specific to some case studies so that we can appreciate that how this thing work in real world. So I'm going to talk about two case studies, and I will discuss the case study and then also show the code as well, and then I will run that code and then you can see the output, and I'll explain that output. So the first case study is the detection of command and control. In this particular case study, the attacker is doing communication with a command and control center, which could be a DGA based DNS domain or non-DGA based domain. And in the case of WannaCry, there was a one CNC where the attacker was using for the communication to get the encryption key or to send the encryption key over there. And typically, ransomware or malware needs to do that communication to get the next set of instructions or to get the keys exchange done over the server. Now, how do we do this kind of CNC detection using the data science? So this shows the DNS logs, and we can't really analyze all this. So we have to use some kind of parser, and that parser and indexing all has to be done. So this one is done in Splunk. And then we need to train a classifier. So we are using a random forest in this case. I'm not going to talk about the random forest in detail as such. I'm assuming that audience has a basic background in machine learning. But essentially, random forest is a tree-based classifier, and it is using an ensemble of trees to enhance classification accuracy. And so in this particular case, we are using a multiple features to train a random forest, and I will show that in the demo. So what's the data processing pipeline? The pipeline is showed over here. We have DNS data, and we may have the previous alerts. So we can leverage the data from previous alert as well. And then we train a classifier for the benign and the malicious CNC domain. And I gave you some examples of CNC domain here, like here. These are the few examples of CNC domain. And if you look at the good benign example, that is something like google.com or say something like bbc.com or cnn.com. These you can pick up like the top 1 million websites in Alta Vista, the benign websites, the benign DNS domains. Those are used by the normal users on a daily basis. So those are like the benign. And we have to keep updating this benign list and also keep updating the malicious CNC, malicious domain list as well. And then train the classifier. And in this particular case, we are doing the CNC detection for the ransomware, and we did it for the 20 ransomware families, and we are able to detect with 100%, nearly 100%. It shows like some 97% precision here and some 2%, 2.5% false alarm. And all these on the right side, this shows the ransomware family names, and then it shows the number of URLs which were reported by the tool, by this particular algorithm. And then the actual CNC URLs were shown in the red. So there is a good match, nearly 97% precision. We are able to detect them. So let's see a demo of this. So I'm getting into my Python notebook, and this one shows the CNC detection demo. I have a bunch of libraries which I have, plots and the classifiers which we need to import. And this is the training data which we have imported. And then we are using bigrams and trigrams for each domain and as a feature along with the entropy as well. So let's look at some of these features. So I'm going to show them here. Uh, so this one shows that how do we create the bigrams and trigrams. And this shows for an example of google.com. This shows a bigram, how the bigram looks like for google.com or google.co. In this case, the last domain, the co.in, we dropped the last one, the last subdomain. So .in is dropped. So we are creating the bigrams of google.co. And then we also create the trigrams as well. Well, in this particular case, we also compute the entropy as well. So we compute entropy for each of these benign URL, and the bigram score is computed from based on all the bigrams, depending on what's the bigram frequency for each of the bigram, and then divide by the total number of bigrams and so on. And the trigram malicious is 0 here because there is no malicious URL here. If you look at the malicious URL, for them the trigram malicious score shows up. And if you look at here, the distribution of these bigrams and trigrams for benign versus malicious, it is different. For benign, it has a different distribution, and for a malicious, it is a different. So that actually helps to do the classification between a benign versus a malicious domain. Now, this shows that this feature is a discriminative. Now, we could also leverage other features as well. Here, we are leveraging trigrams as well, along with the entropy as well. So we take all these features and train the random forest classifier. In this particular case, we got the classification accuracy of 97%. And this shows a precision recall curve for that. It looks pretty good. We can further increase the accuracy as well if we enhance the training data, and as well as maybe a different set of algorithms as well. So depending on the data and the type of classifier, the accuracy can be further increased. So this shows an example that the trained classifier is used to predict for some domains, are they malicious or benign. So for google.com, it shows the score is very less for malicious, but for this particular URL, DNS name, this is malicious. And we can use this to automatically predict whether a DNS server is benign or malicious. Okay, so we discussed about CNC detection using a supervised machine learning. Let's discuss another case study. So this case study is about Windows PowerShell. Attackers use the PowerShell as well, along with our system admin as well. So we all know that system admins love Windows PowerShell because it is such a powerful tool. It helps them to do a lot of scripting and do a lot of automation, do the registry changes, do the get processes, and many of the automation can be handled by Windows PowerShell. And there are for some more use cases I have listed here, setting up the environment variables and so on. Now, attackers also love PowerShell because most of the commands are executed in memory and no footprints are left in on the disk. So which actually helps the attacker because it's not on the disk. So here is a command which, as an admin, we would write that command and it will give this result: get process where the processes are having handles more than 600. So we just run this on, first we run PowerShell on the command prompt, and then we run this command. The command is shown over here. Then it will give me this particular output. Now, another thing what attackers do is they obfuscate the command. So instead of writing this command like this, you obfuscate it. So the same command which I showed here, the get process where handles greater than 600, sort handles, format table, this is now obfuscated. And this obfuscated PowerShell script looks like this. So this is very hard to detect it in the enterprise because it is now obfuscated. And this obfuscation can be done very easily with a simple string processing and with the regular expressions. And this is just shown for one type of obfuscation. Now attacker, instead of writing that command, he can just run this particular command in a PowerShell file, which is named here in pso1.ps1. He can just call this particular file in execution policy, and which is also a very benign command. So it makes very difficult for uh, the admin and also for the enterprise to figure out whether it's a benign or a malicious, or whether this obfuscated command was actually ran or not. If you're logging all the commands which have been ran, this will be shown as an obfuscated. You can't figure out what was the command actually it was ran. Now this shown as an obfuscation of type 2. Here it has been further obfuscated. So it is very hard to figure out from the command from pso2.ps1. This is the file which has this particular command, the same command. Now it makes even more complex. That's where the machine learning is very powerful. We can take all these examples and we can train a machine learning classifier to do an automated detection of whether there is an obfuscated command being ran or a benign command was ran. So was there any obfuscation done? Yes or no? So how do we do that? We take the scripts, let's say the clean scripts, we use an obfuscation tool, and those obfuscation tools are actually also available online. As a defense team, we can also use it, and attackers also use it. We can train, we first compute the features. Those features are like the character label bigrams, and then we give it to a random forest classifier, and that trained model is used to predict whether this is obfuscated or no, yes or no. So let's see a demo of that. So what you see here, this one shows that there are different types of obfuscation being applied on a clean script. So this is a clean script which was not obfuscated. Now this is being obfuscated, and now this becomes obfuscated script. This is another type of obfuscation. So this same script here, which was like so clean, well readable, and you can see what has been done. We can use a tool to obfuscate like this. Now it is very hard to figure out what commands have been done, what this script does. Now if you further complicate, you further obfuscate, now it becomes very, very difficult to even retrieve what was done. So there are multiple machine learning challenges here. The first challenge is to first figure out whether the obfuscation was done, yes or no, automatically, without looking at each script manually. And then second thing is to retrieve the original commands as well. So in today's demo, I'm going to talk about how do we do this automated detection of obfuscation, yes or no, whether obfuscation was done or not. So we have to do some pre-processing, just remove some spaces, remove some of the other delimiters and make it clean. And after pre-processing, this is how it becomes. Then we compute the character level bigrams and the unigrams, and those are being done here. And this shows the character level bigrams and unigrams for the clean script versus the obfuscated script. So as you see visually, these character level bigrams are different for the clean script versus the obfuscated script. Now, if we give this data to the classifier, it is going to do the classification. So we do this analysis over a corpus, and we took a big corpus of some hundreds of scripts, and we learn these unigrams and bigrams, and this shows the distribution of unigrams for the clean scripts, and this one shows the distribution of the unigram and the bigrams for the malicious scripts. Not really malicious, I mean like obfuscated script. A script could be benign or malicious. We are just talking about whether it is obfuscated or not. So here, this shows that the distribution is sort of different. The green and the red are sort of different for the clean and the obfuscated. So we take these unigrams and bigrams and we train the random forest classifier, and then we use that for prediction. And when we do a prediction over a large number of scripts, we get the precision recall curve, and this shows a precision recall curve. This is pretty good. It's above 0.9 is the average PR value, so that's pretty good. And then also the precision value is 98%, recall value is 94%, and then the accuracy is 88% or so. So this shows an example where machine learning is very powerful in doing the classification of obfuscated versus the clean script. So let me summarize for a security data science what we have discussed so far. We have discussed that the security data science has gone through its own evolution over the few decades, and there are large number of data sources that can be leveraged to find the attacker activities and the attacker techniques and the tactics used during his presence in the enterprise. I have shown only 2 case studies, but there are large number of use cases and large number of case studies which are being possible using the data, and we can leverage both anomaly detection and also supervised machine learning approach to do the detection of attacker activities. Now, there are some disadvantages. Uh, Unfortunately, it gives us too many alerts and too many false alarms. And it is very hard to give the labels. And that's where sort of like the next generation of tools and next generation of startups are coming up, where they are trying to overcome these disadvantages. So if we want to leverage data for the security, definitely this is the golden opportunity. We have the tools, techniques, and the infrastructures which are quite mature now, and we have to blend that with the domain knowledge which security analysts have to find and to make this, to find the attacker activities and also make our defense much more stronger. So just I would like to add in more in a philosophical end. I have built data science products in multiple industries, and it's like sort of like rock climbing. Lot of challenge, lot of unknown, and we need to figure out the route. The same thing is for the data science field as well. I typically pick up a domain and then go deep at it. And here is a URL. I would recommend if you really want to get into the depth of security data science. There are lots of papers and a lot of interesting presentations also listed over here. So you can take a look at that. And I think now I'm ready to take the questions. So over to you, Vedant.
Thank you so much, Dr. Satnam, for this really empowering session. You can take up the questions that are displaying under the question tab.
Okay, so Harmeet Singh has asked a question. Is that cybersecurity different from network security? Excuse me. Harmeet, thanks for asking your question. Cybersecurity is more of a big umbrella which has a lot of subfields. It also has endpoint security. It also has a network security. It also has privileged user security. I mean, like if I talk about, then there are roughly more than 200 plus companies working in this cybersecurity, and in the network security, maybe 15 to 20 major companies. So this is a big domain. Cybersecurity is a big domain, and the network security is a part of it. And if you look at my webinar part 1, I have shared the landscape of cybersecurity, and you can get a lot more information about it from my part 1. So next question is from Tarun Kumar. As attacker think like Blue Man to attack enterprise, so why Blue Team doesn't think like attacker? Things can be different. Well, you are absolutely correct that everybody has to, it's sort of a game. Blue team and the red team. The red team is the attacker and the blue team is the defense team. The problem in this case is for the blue team, the things are everything more or less everything like 80-90% is in public. You can read about, we come to know about attacker. We can only know about attacker from the traces, from the signals what they have left when they did an attack. But they don't have anything like a published website or published places. Okay, you have to go on the dark web and then mine about their about them. They are very secretive, very they are hidden in the dark web. But for the blue team, it is actually everything visible. So this problem is asymmetric. First of all, if the attacker, if the blue team writes a 10,000 lines of code to prevent the attacker to steal it, but then attacker can easily write 2 lines of code to evade that. So it is very, the defense team as such, defense job is very difficult as such. Now both of us, the blue and the red, they think about their strategy. They think about, not only think, they also study very deeply. And as I said, because of two issues, the problem is very asymmetric. And then the second thing is, for the blue team, the things are more in the open, and for the red team, for the red, not team, the red team is typically called as a pen tester team in the security area. But here I meant like the attackers, for the attacker activities, uh, those are more hidden, and you don't know about them. So blue team is constantly thinking about how attackers are doing their attacks. And if you go to the Black Hat conference, their videos, you go to the RSA conference, their videos, you will know the state of the art techniques and tactics which are leveraged by the attackers. And those videos are typically done by the blue team. And also by studying them, then we make our defense stronger as well. And then as a blue team, we also think the role which is actually played, like how to think like an attacker, that role is being played by the pen tester and the red team. That's what typically happens in the security industry. So Manoj Kumar is asking a question. Please explain re-arm value. Okay, now just a minute. A random forest use which order, pre-order, post-order? I think Manoj, I'm not getting into the details of the random forest as such, and I didn't really get your question properly, pre-order or post-order. If you can write your question again, a little more detail. I didn't get your question, pre-order, post-order. Okay, I have shown the random forest classifier that is being leveraged after you done a feature processing. That's what that's where you do the classification. So next question is by Manu. How they classify these domain as malicious and what it is checking? No, I showed that in my demo, that the malicious versus benign domain, typically not just a one technique being used. In this particular demo, I showed that the machine learning classifier can be leveraged to do the malicious versus benign. And I have shown that in my demo that we can do a feature engineering first. We can construct the bigrams, trigrams, compute entropy, and feed those features to a classifier, and then classifier would say whether it's a benign or a malicious. Okay, so Mayank is asking a question, which is the best classifier with respect to accuracy in terms of huge data? So Mayank, that's a good question, that when you have a more of a big data scenario, how do you pick up a classifier? So I would say that pick up a classifier which can be parallelized. So random forest can be easily parallelized, and it is one of the well-known and well-established classification technique. Another one is logistic regression, which is also very popular in the industry. If you go in the academic world and you go on the Kaggle, and also the latest deep learning classification, like in the deep learning, we can leverage the feed-forward neural network. So that also works pretty good for the big data or the large data scenario as well. Typically in security industry, I've seen that logistic regression being used, and that is because that it can also give you random forest also, because it can give you the features which are responsible for the classification. So you can get some more insights from the output, and that's what the security analyst also would like to see. So the next question is from Anna. How to differentiate between a false alarm and actual treat? Well, um, you need to have a ground truth. So in this case, we had a ground truth, and we knew that this is a malicious, this is an obfuscated script, or this is a clean script, or in the other case study we knew that this is a benign versus a malicious domain. So we could leverage that to figure out how good is our algorithm, right? So during your validation data set, you know that, okay? But in practice, in the real world, it only comes to know when the analyst looks at, and then he has to investigate that particular alert, and then he has to label it whether this was a false alarm or not. And that's where the challenges of doing the real world implementation comes into practice, comes into picture. Okay, so Binu has asked a question whether any certification available. There are there are a lot of courses being offered and certifications being offered. SANS is one of them, but SANS is typically very costly. SANS, if you look at SANS, 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 and then if you look at Cybrary, Cybrary, Cybrary. Cybrary also gives some of the certifications, and there are a lot of CSS, Cisco level. Cisco also offers some security certifications as well, and also I'm not sure whether they offer in a security data science or not. But there are a lot of good open source. So open, I would say, like, pick up few open sources like some of the Coursera, Udacity, Udemy. Udemy has a whole bunch of courses as well, so we can take it from there, and those are pretty cheap as well. Udacity, Coursera, and some of these MOOCs are actually offering them as free, and if you need to get a certificate, then you pay for it. So there are a lot of sources available, and these are the places where to start more deeper into this area of security data science, along with the information security as such. So Shubham Mitra has asked a question: do you think as proactive measure static code analysis may help for better coding practice in data science? Is there any such tool so far available? So this particular question is a little far away from the information security topic what I discussed. Static code analysis could be useful from different for different industries as such. But if you talk about more like what are the good coding practices for to write a code safe and secure, that is definitely a one sub industry uh, in the security area, in cybersecurity area, and data science can definitely be leveraged. We have to collect such code and then give it to the machine learning and deep learning techniques. And I think in this particular case, a recurrent neural network may be very useful because we can train the sequence of commands and it can output a sequence of commands. So this is just a very initial thought, but I'm pretty sure that data science can be leveraged in this area. Okay, another question is from Suresh. How to remediate vulnerabilities in data science? Okay, so this is very interesting question. So I think what Suresh is pointing out that the data science or machine learning algorithms itself can have holes and vulnerabilities which can be leveraged by attacker. So for doing that, we have to understand as a data scientist that what attacker can do and how he can patch it. For an example, if we have built an algorithm with very less data, and if we publish those details also in open, then and if that comes in a product and attacker also knows it, then he can easily bypass it by changing. See, for an example, like I showed in today's webinar, that DGA based domain generation algorithm based domain, the malicious domain, right? Now attackers also know that the blue team is using the DGA based uh, domains as a data to train the classifier. Now if we leverage only these published features, then it will be very easy for him because he can craft the domains which are looking very like a benign. My site is all good, right? Something like my site is umbrella. Now that is a very good word, right? It's not really a random generation of a domain. And that's what attackers are doing it, right? The moment they come to know that the defense team is leveraging data science, machine learning to look at the random domain, in that case, they started using the domains which have a well crafted name. Now this makes the blue team job or the data science team job even harder. Now you have to craft new features, or you need to have a lot more data along with the new tricks and techniques to detect these more normal benign looking domains. So it's a game. It's a game between the blue team and the attacker. And I think with this, there's one more question here from Mohammed. Where can I find ML projects on log files anomaly detection? So the link that I shared here towards the end, it has a bunch of links, sublinks as well, which points to the data. Getting the data is very important, and that is almost like sort of like 30 to 40 of the problem, getting the data itself. But there are good data sources available now, and I have listed them here. And if at all you can't find them, you can find me on LinkedIn and you ping me, and then I can help you on giving you further details of what are those data sources. Okay, another question. I think okay, so Manoj Kumar has a question that algorithms like tree traversal, in-order traversal, pre-order traversal, or post-order traversal. Okay, I got it, Manoj. So when we talk about a random forest, this is different than the tree-based algorithm what we have seen in our algorithms. This one is more like you have a set of features and you have the label available, and you train an algorithm which looks at more like an entropy of you give like a training data and then the testing data, and then you train the classifier. So it looks at the feature space, and the feature space which it looks for the hyperplane which can classify a benign versus a malicious. So this is a different than the normal tree-based algorithms uh, in the algorithms and the data structure course. There, it is more like you already have a well-defined uh, data in which you need to construct the tree for some kind of a depth search, either a breadth search or a depth search, and you're doing some kind of a search problem. Here, our problem is more of a classification problem, where we have to provide the data, and it's more of a training and testing, classifying the data first into some training and testing, and then leveraging the features and giving it to a classification algorithm to say automatically and predict whether this is class 1 or class 2. Okay, so I think with this I'm at the end of my questions, and I appreciate your time, and thanks a lot for attending the webinar and asking the questions. It was nice pleasure to meet you over here at the webinar, and I wish you all the best for 2018. Over to you, Varun. Vedant.
Thank you so much, Dr. Satnam, for this really empowering and motivating session today. I would also like to thank all our participants for making this webinar a great success. This session has been recorded, and the recording will soon be available on techgeek.com. Thank you everyone for joining us.